Hello, welcome to my video. Today I'll be testing the reducing strengths of 4 metals, such as copper, lead, zinc, and magnesium. A reducing agent is a substance that loses electrons, causing another substance to be reduced. I'll react each solid metal with aqueous solutions of the other metal's nitrates, and I'll observe color changes, temperature changes, and pH changes, and metal appearance. And I'll record volumes before and after reactions to confirm whether displacement occurs. From these observations, I'll determine which metal is the strongest reducing agent. So for each experimental setup and for each trial, I'll take a clean beaker and I'll pour 30 milliliters of a metal nitrate solution into a beaker, and then I'll add 10 grams of the solid metal to the solution. I'll watch carefully for any color changes, temperature or pH changes, and metal surface changes, such as lightning. I'll record the volume of the solution before and after the reaction. And if a reaction occurs, the metal loses electrons and is a stronger reducing agent. If no reaction occurs, it is weaker. I repeat this for all 4 metals with applicable metal nitrate solutions, keeping the mass and volume constant to make results comparable. First, we're going to start with the copper experiment, copper metal, and its appearance is reddish brown, so that would be under qualitative observations. And first, we're going to pour 30 milliliters of the zinc nitrate solution into a clean beaker. So I'm going to put 30 milliliters of zinc nitrate. And now we're going to dispense 10 grams of copper solid into the beaker and observe if there is any changes going on. And as you can see, there isn't really any reaction going on. There isn't any changes that we can observe by the eye. And however, the volume did change to 35 milliliters because we initially started with 30 ml of the aqueous solution, and then we added the copper solid, and then the volume has changed. Therefore, under quantitative observations, we can say for zinc nitrate, we started off with 30 milliliters, and then after we added the copper solid, we can assume, based off our observations we made of the reaction, that we went up 0.5 milliliters, so from 30 to 35. 5 milliliters. And to mention, for the qualitative observations with zinc nitrate and copper metal, as we know that zinc nitrate is clear and colorless solution. However, reaction was not really occurring, and we could see and make observations and notice that nothing was really going on by the naked eye. Next, we're going to do magnesium nitrate as our aqueous solution. So we're going to pour the same amount, so the volume is constant, so it's going to be 30 ml of magnesium nitrate into our clean beaker. And we're going to dispense also 10 grams of our copper solid into the solution. And we're going to make observations. And based on our observations here, there's really no reaction going on here. However, I do notice that the volume has changed to 35 milliliters, so we can make that as our quantitative observation. But for qualitative, I see no reaction occurring. Therefore, we can safely assume for magnesium nitrate, before it's a clear colorless solution. However, there was no really reaction occurring, so we cannot make any notes for our during or after. And then for our quantitative observations, we can safely assume that we started with 30 milliliters of the magnesium nitrate, and after we added the copper solid, we ended up with 35 milliliters. Lastly, we're going to end off this trial or this reactions with our lead nitrate solution. So we're going to add lead nitrate into the clean beaker. So we're going to add also 30. We're going to pour that in there. And then we're going to dispense 10 grams once again into the beaker of copper. It's 10 grams of copper, like so. And once again, I do not observe any changes occurring, or any reaction occurring. However, I do notice that the volume did change. So we can make observational, a quantitative observations for that. For the quantitative observation for the lead nitrate, we started off with 30 milliliters, and once we added our copper solid, the volume has changed to 35 milliliters. However, comparing that to the qualitative observation table, we started off with a clear colorless solution for lead nitrate. However, no reaction occurred. Hence, copper did not react with any of the metal nitrates, and this demonstrates that the copper is the weakest reducing agent. Now we're going to test lead metal, which is dark gray in the physical appearance. And first I'm going to pour 30 milliliters of the copper nitrate into the clear beaker like so. And now I'm going to add or dispense 10 grams of lead metal into the beaker. And as you can see, a reaction does occur because there has been a change of color. We first started off with copper nitrate, which is blue in color, and then after we added the lead, it turned into clear. And also, we can also assume that during the reaction, the temperatures has changed when the reaction was occurring, and the pH level did change. And after the reaction has occurred, the solution just stayed clear and colorless. Metals turned lighter in color, and the reaction, we can assume it does occur. We can also say that there has been a change of volume because we did start off with 30 ml of the solution, and then after we dispense the solid of lead, it did change. Now we're going to add 30 milliliters of the magnesium nitrate into the clean beaker, like so. And we're going to dispense 10 grams of the lead once again to observe if there is a reaction occurring. And as you can see, nothing is really happening. No observational changes are occurring. However, we can assume that the volume did change because we started off with 30 milliliters and we ended off with 35. However, there has been no change in pH or temperature or any of that aspects. Hence, we can assume that a reaction does not occur. Lastly, we're going to test zinc nitrate. So we're going to add 30. And we're going to dispense 10 grams of lead into the beaker and make observations. And once again, I see no clear changes or no observational changes. However, I do see quantitative changes in terms of volume because we went from 30 milliliters to 35 milliliters after adding the solid into the solution. However, I do not see any pH changes or any changes within the temperature. Therefore, the reaction does not occur. Hence, lead reacts only with copper nitrate, making it stronger than copper, but weaker than zinc and magnesium. Thirdly, we're going to test zinc metal, which is gray in appearance. So first we're going to test the copper nitrate, and we're going to pour once again 30 milliliters into the clean beaker. And we're going to dispense 10 grams of the zinc metal into the beaker and see if we can make any observations. And as you can see, a reaction does occur because the temperature does changes, right? The pH level also changes, right? And the metal turned lighter in color, and also the solution did change in color as well. And after the reaction has occurred, we can assume that the solution is clear and colorless and metal turned lighter in color, and we can safely say that the reaction does occur because we made these observational Next, we're going to test the magnesium nitrate with the zinc. So we're going to add 30, like so. And we're going to dispense 10 grams of our zinc and see if we can make any observations. And as you can see, I see no change in qualitative observations. In terms of the change of appearance, I don't see any. However, I can make quantitative observations because the volume did change from 30, because we started off with 30 milliliters of the aqueous solution, and as we added the solid, the volume has changed. However, the temperature and the pH stayed consistent or constant. Therefore, we can safely assume that the reaction does not occur. Lastly, we're going to test lead nitrate with the copper solid. So we're going to add 30 milliliters of the lead nitrate, like so. And we're going to dispense 10 grams of our metal into the solution. And as you can see, the temperature does change, right? And the pH levels do change. However, I do not see change in the color, but because of the change of temperature and the change of pH, we can safely assume that the reaction does occur when we mix zinc, solid metal, with lead nitrate. Finally, I'll test the magnesium, which is light gray in physical appearance. So first, I'll pour 30 milliliters of the copper nitrate into the beaker, like so. And I will dispense 10 grams of the magnesium solid into the beaker. So as the reaction is occurring, we can observe that temperatures do change, the pH level does change, and as the reaction is slowly slowing down, or after it's done, we can assume that the metal does turn lighter in color. And based on these observational changes, we can assume that the reaction does occur when we mix magnesium solid and zinc nitrate. Now we're going to add copper nitrates into the clean beaker like so. We're going to add 30. We're just going to add 10 more. Now we have 30 milliliters of the copper nitrates into the beaker. And now we're going to dispense 10 grams of our magnesium and see if we can make any observations. As a reaction is occurring, we can determine that the temperatures are changing, pH levels are changing, and after the reaction is completed, the solution does turn clear and colorless, and the metal does turn lighter in color. And based on these observations, we can safely assume that the reaction does occur when we mix magnesium metal with copper nitrate. Lastly, we're going to test the lead nitrate with the magnesium and see if we can make any observations. First, we're going to add 30 milliliters of the lead nitrate. I just grabbed some more lead nitrate to add. Now we have 30 milliliters of lead nitrate, and we're going to add magnesium solid 10 grams into solution to see if we can make any observations. Now, as you can see, we can observe that there has been temperature changes, pH level changes. However, I do not really see any changes with the solution color, but I do see changes of the metal as it turned lighter in color. And because of these observational changes we can see during the reaction does occur. Therefore, magnesium reacts with all other metals, making it the strongest reducing agent. And in conclusion, the strength of a reducing agent is determined by whether it can displace other metals from the solution. Metals that react with more solutions are stronger because they lose electrons more easily. And because of this, magnesium is the strongest and copper is the weakest. Also, to conclude, the final order of the reducing agents, based on the reactions, would be magnesium is the strongest reducing agent, then zinc, then lead, and copper will be the weakest reducing agents.